In this video, we are going to talk about composition of functions, and the definition is f composed with g of x equals f of g of x. So let's take a look at a few examples. But before we do that, let's remember, if I have f of x equals x squared plus 3x minus 2, what it means is whatever quantity I have here is going to be squared, then is going to be added with 3 times that quantity and subtracted 2. So if I say f of a, for example, everywhere I see the yellow part that I highlighted, or the x, is going to be replaced with a. So a squared plus 3a minus 2. So this one, right, everything stayed the same if you compare them. Now if I ask for f of g of x, so what's going to happen, right, I'm going to trying to get to the definition. We are going to replace in f of x, instead of x, we're going to put g of x. So it's going to be g of x squared plus 3 times g of x minus 2. So this is going to be like that. As you can see, the 3 and the 2 and their signs stayed exactly the same. So let's do a few examples with composition of functions. So let's say we have f of x equals square root of x and g of x equals x plus 3. If we want to find f composed with g of x, using the definition, it's f of g of x. So everywhere we see in f x, we are going to put g of x. So it's equal to square root of g of x. But g of x, we already know what it is, so it's going to be square root of x plus 3, right? G of x is given by this expression, so we got square root of x plus 3. So if you think about it, the interior, we have f of something. So we had an interior function, which now is going to be under the square root. So the f is the exterior function, so the square root is outside. And then there is an x plus 3 as a g of x, which is in interior, so we have x plus 3 under the root. So it became an interior function. You'll see why I'm specifying that. Let's see example 2. F of x equals 1 over x, and g of x equals x squared plus 9x minus 3. So f composed with g of x, it's f of g of x. So again, we take a look at f of x, it's 1 over x. So in our case, f of g of x is going to be 1 over g of x. But g of x, it's given by this expression, so we are going to put 1 over x squared plus 9x minus 3. So if you notice, this interior function, it became the denominator of our functions. Which one is exterior? 1 over x. And let's take a look at the example 3. F of x equals x to the 10. G of x equals x minus 4. And we want to find f composed with g of x, which is f of g of x. I want you to think, how would g composed with f of x look like? Anyway, going back to our problem, f of g of x and f of x, it's x to the 10. So f of g of x is going to be g of x to the 10. But g of x is x minus 4, so it's x minus 4 to the 10. So again, we can see easily how this g of x, which is in interior, right, of this parenthesis, is actually in interior of this exponent as well. Now let's take a look at each of these problems and discuss a domain. So the domain of this one, well, if we think about it, x, it's in the domain of g of x, and g of x, it's in the domain of f. So do we have any restrictions for x in g? Well, the function g of x, it's a linear one, so it's a polynomial. It doesn't have any restrictions. Now, when we look at g of x inside f, right? If we take a look at this one, there is a restriction, right? X plus 3 has to be greater than or equal to 0, which is x greater than or equal to negative 3. Or the domain is from negative 3 to infinity. Now let's take a look at the next problem, at the second problem. We ended up with this. So first of all, is x restricted in g of x with anything? Is not, right? It's a quadratic, it's a polynomial, so no restrictions. Well, when we take a look at the composition of functions, we have a denominator. So x squared plus 9x minus 3, if we set it equal to 0, we are going to find out the values for which this expression is undefined. So this one, we can try to factor it, or we can try to use quadratic formula, which is 9 plus minus square root of, it's negative b plus minus square root of b squared minus 4ac over 2. So it's negative 9 plus minus square root of 81 plus 12 over 2. Negative 9 plus minus square root of 93 over 2. Interesting number that I chose. So basically, the denominator cannot be these numbers. So if I split them, is negative 9 minus square root of 93 over 2 and negative 9 plus square root of 93 over 2. So we have this negative number and positive number. So on the number line, negative infinity, positive infinity, these two numbers cannot be. So the domain is going to be, so which numbers are here? This one would be the negative one, and this one would be the higher one, right? Which I think it ends up being positive. So the domain is from negative infinity to negative 9 minus square root of 93 over 2, open interval, union negative 9 plus square root of 93 over 2 to infinity. This is the domain of the second problem. And now let's take a quick look at the third problem. Again, g of x, no restrictions because it's a linear one. And f composed with g is x plus minus 4 to the 10. No restrictions there either. So the domain is from negative infinity to infinity. So now a quick problem that will justify why I was talking about a function inside, internal function. Let's take a look at this example. For example, h of x equals 4th root of x squared minus 2x plus 3. So if we have this, can you try and figure out for me what's f of x and what's g of x, so that f composed with g of x is h of x, or in other words, decomposition of functions. So I want you to think out of here, it's a combination of two functions, 4th root of x squared minus 2x plus 3. If you were to split this into an inner function and outer function, which one would be the inner function? Well, under the root is this one, so this would be the inner function. Which one is the inner function in the composition of functions? Which one is inside? G of x. So basically the g of x is the x squared minus 2x plus 3. And the outer function is what? Where was this inside, this inner function? Well, it was inside 4th root of x. And you can quickly check by doing f composed with g of x is f of g of x, or 4th root of g of x, which is 4th root of x squared minus 2x plus 3. And let me do one more of these decompositions. If h of x is absolute value of x minus 4, what would be f of x and what would be g of x? So the inner function, it's x minus 4, so that would be our g of x. And it's inside of what? Of an absolute value function, which is absolute value of x. This f of x, these outer functions, are actually parent functions that we talked about last time. I hope this helps.